if you consider a current carrying wire, then using the right hand thumb rule, you can get an idea of the magnetic field. Now, if we look closer, the current is generated due to the flow of electrons in the opposite direction. That means the moving charge is generating the magnetic field. But why? That is what we are going to discuss in this video. Let us denote the velocity of the electron by v vector and consider two frame of reference, S frame of reference which is sitting on the electron and S prime which is observing the electron in motion. Now, according to S, the electric field lines will be converging towards the charged particle. So, electric field will be non-zero. And since with respect to S, the electron is at rest, so the magnetic field will also be zero. Now, what will S prime observe? Will it observe the same electric field or something different? According to S prime, the charged particle will be moving, so the electric field lines will also be moving like this. So, electric field will be non-zero, but it will be different. Since the charged particle is in motion with respect to S prime, it will be also generating a magnetic field as the charge move. So, the magnetic field will also be non-zero. Now, let us compare the observations made by S and S prime. So, S frame of reference says that the charged particle is at rest, but S prime says it's in motion. S says that the electric field is non-zero. S prime says, no, the electric field is non-zero, but a different one. Again, S says the magnetic field is zero, but S prime says, no, the magnetic field is non-zero. So, both the conclusions are different. So, what did S and S prime did is, they took their conclusion and checked with the Maxwell equations, because that's the ultimate equation. And both of them found that it agrees well with the Maxwell equation. So, what is happening here? Let us go deeper inside and see what is happening. Here you have a charged particle Q, and at time t1, the electric field at point P is given by E vector. Now, at time t2, the position of the charged particle is changed. So, the new electric field at point P is denoted by E prime vector. Now, how fast does P knows the charge has moved? Now, this time, it is given by R by C, where R is the distance and C is the speed of light. Since speed of light is coming into picture, that means relativity is coming into picture. Now, because of this, electromagnetic interaction happens at the speed of light with a delay of R by C. Since relativity is coming into picture, we have to use the field transformation from one frame of reference to another frame of reference. Now, let us take a simplified case where S frame of reference is moving with the velocity v. Then the electric field component and the magnetic field component will transform by these formulas. Don't worry about these formulas. We'll deal with them one by one in a very simplified manner. Let us take the first two formula. So, in the first formula, the parallel components will remain the same. But in the second formula, since according to S frame of reference, magnetic field is zero, so the perpendicular component gets modified by a factor of gamma. Now, let us move on to the third formula. So, here, since according to S frame of reference, the magnetic field is zero, so the parallel component will be zero. So, Now let us take the fourth formula. In this formula, the B perpendicular component according to S frame of reference will be 0. So these are the four formulas. Now if you combine all the four formulas, you can say that the S prime is observing a non-zero electric field, but it is different from the one observed by the S frame of reference, and the magnetic field is non-zero according to S prime. So the difference in observations between S and S prime frame of reference is because of the relative motion between S and S prime and the relativity which is coming into picture because the interaction is happening at the speed of light with a delay. Now I want to show you something interesting with the fourth formula. In this expression, we can substitute E by using the electrostatic expression for a point charge, that is E is equal to 1 by 4 pi epsilon naught q by r square into r cap. So if I substitute this expression, then I'll get this expression. Now if I rearrange this expression, then we can write it like this. Now the epsilon naught c square factor, which is in the denominator, I can replace it by 1 by mu naught. And since the electron is traveling at a drift velocity, which is very much less than c, so this gamma factor we can equate to 1 and we'll get this final expression. Have you seen this expression before? Yeah, this is another version of Biot-Savart law. From here we can see that by using field transformation, we can even derive the Biot-Savart law, which basically gives the magnetic field generated by a current carrying element. Thank you everyone for watching this video. Take care.